The invisible elixir of life, oxygen, is everywhere on Earth, shaping the very essence of our existence. This life-sustaining gas, constituting about 21% of the Earth's atmosphere, plays a pivotal role in the survival of countless species. The Earth will not be able to support and sustain life indefinitely. According to a new study published in Nature Geoscience, our oxygen-rich atmosphere may only last another billion years. As our sun ages, it becomes more luminous, implying that Earth will receive more solar energy in the future. The Earth's atmosphere was dominated by carbon dioxide, methane, and water vapor. Scientists predict that the Earth's atmosphere will revert to a low oxygen state in the future. The stability of the Earth's oxygen-rich atmosphere is affected by a number of factors, including biological, chemical, geological processes and human activities. 1. Biological processes. Oxygen is continuously produced through photosynthesis, primarily carried out by plants, algae, and cyanobacteria. These organisms take in carbon dioxide and release oxygen as a byproduct. As long as photosynthetic organisms are thriving, they contribute to the maintenance of an oxygen-rich atmosphere. 2. Chemical processes. Chemical reactions such as the oxidation of minerals and metals can also consume oxygen. These processes help to control the amount of oxygen in the atmosphere. 3. Geological processes. The geology of the Earth, including volcanic activity, can influence the composition of the atmosphere. Volcanic eruptions emit gases, including sulfur dioxide, which can interact with oxygen. However, volcanic activity contributes to the release of gases such as water vapor and carbon dioxide. 4. Human activities. Regardless of these factors, the balance of oxygen production and consumption has remained relatively stable over geological timescales. However, human activities have an impact on the long-term viability of an oxygen-rich atmosphere on Earth. Deforestation, industrial processes, and the use of fossil fuels all contribute to elevated carbon dioxide levels, which can alter the overall composition of the atmosphere and cause climate change. A study on Nature in 2021 describes the scenario when it will happen. That time is still a billion years away, but when the change comes, it is going to happen fairly rapidly. The shift will take Earth back to something like the state it was in before what's known as the Great Oxidation Event, GOE, around 2.4 billion years ago, said the study. The study has resurfaced as scientists look for habitable planets outside the solar system. It is predicted that atmospheric oxygen will not be a permanent feature of habitable worlds in general. Scientists who foretold the doomsday scenario stated the study, the model projects that a deoxygenation of the atmosphere, with atmospheric O2 dropping sharply to levels reminiscent of the Archean Earth, will most probably be triggered before the inception of moist greenhouse conditions in Earth's climate system and before the extensive loss of surface water from the atmosphere. Scientists have created two hypothetical scenarios, one with an Earth-like planet and an active biosphere, and one without. Surprisingly, both scenarios produced broadly similar results. This finding suggests that, while falling carbon dioxide levels and plant photosynthesis do have an effect on oxygen levels, the effect is secondary to long-term interactions between the mantle and surface environments. In short, the balance between the geochemistry of which rocks enter the mantle during subduction and which gases are emitted from the mantle via volcanoes appears to have the greatest influence on how long Earth's atmosphere will remain oxygen-rich. The study's authors conclude that our oxygen-rich atmosphere may only last 1.08 billion years more. The depletion of oxygen would almost certainly mean the end of Earth's ability to support complex, aerobically respiring forms of life.